integers and negative integer, positive and negative integer. Given an array nums sorted in non-decreasing order, return non-decreasing is like ascending with ties. Return the maximum between the number of positive integers and number of negative. The maximum between the number of positive integers and the number of negative integers. In other words, if the number of positive integers is nums and nums is pos, the number of negative integers is neg, then they return the maximum positive and negative. There are 3 positive and 3 negative. The maximum count among them is 3. The number positive, return the maximum positive and negative. Here the number positive is 2 and the number negative is 3. The maximum count among them is O. Nums is sorted in non-decreasing order. So you just need to know the higher of the 2 counts. Alright, yeah, this seems pretty easy. So the straightforward way would be just to go through the array and oh, I see. So I think here the goal is not to go through all the elements in the array. It's sorted, so you should use a binary search for 0. And if you can find where 0 is, binary search for 0. Excuse me. Binary search for 1. Okay, so the optimization here is like not to do an O of n type algorithm or speed algorithm. It's to do an O of log n or log base 2 of n. Alright, so search for kind of the breakpoint, the middle where positive and negative values meet, and then calculate count based on where that is. Like, you know, if you have the breakpoint be here and ignoring the zeros here, like let's say they were 10 or something, there's the index would be roughly however many negatives there are, and then the length of the array minus that index is roughly how many positives there are, give or take 1 or whatever. And then subtract, find the absolute value of difference. Calculate count of positive, negative. The one or a couple issues is it doesn't necessarily need to have 0, so you can't really you can't require that 0 is down where the breakpoint is. And also there's the issue of duplicates. So if there's more than 1 0, then you need to take that. You need to find like the earliest 0 and the last 0 or something like that. So what I'm going to do is I'm going to, if I were to search for 0 using an arbitrary binary search method, if I were to search for 0 using an arbitrary binary search method, okay, so let's say low is 0, high is let's say n is equal to length of nums, and I'll use this as inclusive indices. So the low index is 0, the high index is n minus 1. While low is less than high, the middle index is going to be low plus high divided by 2. And then if the middle index, let's say mid value, is equal to the nums at that middle index, and if this mid value is greater than or equal to 0, so here there's low index is 0, high index is 6, 0, 1, 2, 3, 4, 5, 6. So your mid index is 3 and your mid value is 3, 0, 1, 2, 3. And okay, let's say the indices are like 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's say those are your indices and your actual values are -5, -4, -2, 0, 0, 0, 5, 6, or 5, 7, 9, something like that. So here your mid index is 4 and your mid value is 0, but you want to go towards where, like, technically you want to go towards here because then you know that you kind of went too far. Anytime you see a 0, there could possibly be more zeros in front of it, and then you kind of don't know, like you can't really assume that that 0 is where your dividing portion to your negatives are. So if your mid value is greater than or equal to 0, then you have to go smaller than that. So I is equal to it's either going to be mid or mid minus 1. I think I'm going to go mid minus 1. So I'm going to search for 0 within this portion. If I know that 0 is found within there. Okay, so at that point, it'll be 0 to 3, your mid is 1, and else, if your mid's 1, then you need to go above that, so low is equal to mid. Alright, at that point, keep on doing that until low is not less than mid, so low is not less than high. So when low is not less than high, then you only deal with one index, which is whatever the low and high index is. And you should, and that number could technically be either negative or positive, depending on whether or not there's actually any negative or positives in this thing. Yeah, so can you solve it? So what you can do here is count negative is equal to, so the low could technically be, so if you have one number, then that number could be okay, what's kind of case where the array is just like all zeros or just 1 0. If the array is 1 0, then low is equal to high already. And if the array is So if it's one thing, it could be positive or negative or 0. And this loop doesn't actually apply. Let's say it isn't 1. Let's say it's all positives. Like it's a single 1. In that case, this would also stop. Let's say it should never really go up, so it should stop in the end. The low and high, the spot for the low, the value of low is going to be positive, negative, or 0, but anything before that should work. And if it's also, but the spot for it could also be negative because the single value could be negative in the nums, in which case you should do one more. So you should do one more than the current, or you should do whatever's less than the current index. Wherever's less than the current index plus the current index if the current index has a negative value. So is index plus 1 if the nums at this index at the low index is less than 0, then count negative should be added with 1. Alright, I'm just going to do a quick verification here that this is all correct. We're counting negatives. Oh my god. This should be low. Is this going infinite somehow? I equals mid minus 1. Yeah, this is going infinite. Mid equals low plus high divided by 2. Mid value equals nums mid. So it's going infinite for this case. So mid is going to be 3. Mid value is 0. So it's going to, because mid value is greater than or equal to 0, then it's going to set high to be mid minus 1. So this high is going to be 2. And then does the next loop. 0 is less than 2, that's true. Mid's going to be 1. Mid value is going to be negative. And because mid value is negative, then you're going to set low to be equal to mid. So it's going to get stuck in here. Interesting. Low doesn't increase, so for a 2-size array, or when low and high are 1 apart, and the mid value is going to be at the low value, or the mid index can be at the low index. And so you're never going to actually move the low index. I think this should be mid plus 1. So yeah, I'm pretty sure this should be mid plus 1. So this might need to be mid instead of mid minus 1. I'm gonna just quickly check to see that that doesn't crash or anything weird. Okay, so there's 3 negatives here, that's correct. 3 negative here, 0 negative here. Let's do a couple more test cases. If they're all negatives, let's say they're all positive. And say, or they're mostly positive. All right, 3 negatives, that's correct, that's correct. I wonder if it actually would work if it's mid, instead of mid minus 1. I have a feeling that might still work. 3, 3, 0, 3, 0. Yeah. Any case, I'm gonna not worry too much about that. So the count low is correct, or the count of negatives is correct, I think. And then the count positive should be low equals 0, high equals n minus 1, while low is less than high. So we basically want to go to where 1 is found. Where 1 is found. Or where the earliest 1 is. Anything smaller than equal to 1. Or anything, the leftmost 1. If is this. If mid value is greater than or equal to 1, high equals mid, else low equals mid plus 1. Okay, so that's going to be and then the count positives will be equal to n minus low at that point. And I think I need to add 1. So because I never actually stick to where that is, just like I never stick to where the 0 is, it could possibly end up being where 1 is. So if nums at low is equal to 1, then count positive plus equals 1. And then I'll just print the count positives just to make sure. Alright, here the count positives is 3. I print out 4, that's incorrect. This is 2, I print out 3, it says off by 1. I think, yeah, this is actually incorrect. It's n minus 1 minus low. Yeah. I think I am taking into account the 1 being possibly in there correctly, but it's just the indexing. Oh no, this is wrong. So it should be 4 there, 0 there, 3 there. Okay, maybe this is off actually. So I'm off by 1 on the ones where 1 is not there. So it actually should be this. And it shouldn't be this. Huh. I think this makes it correct, but there's 3 ones, 3 positives, 2 positives, 4 positives. This should be 0 positives. Should be 3 positives. Okay, so this is incorrect. So what is happening here? So what's happening here is low and high is 0 and 2, goes to mid of 1, which is negative. So that's going to increase the low to be at here. And that should break it, because there's only low and high are equal at that point. So then the count of positives is 3 minus the low, which is currently 2. And so that should stop it. But because this is at a negative, that doesn't mean that so 1 plus 2, so low and high are both at index 2. Low and high are both at index 2. And this is the last index that is good. Normally, what happens? So why does this thing work? Or let's say, why does this thing work? So 0, so this thing stops when it's at index 1. Yeah, this thing stops when its index is 1. 4 minus 1 is 3. So normally it stops when it's at the first positive. Normally stops when it's at the first positive. So what if it's, if mid value is greater than or equal to 0, at that point it would be stopping where it would keep on going till where it's 1, I think. Okay, I'm gonna try that out. This will be off by 1, really. Okay, so that's still 3. That's 4. Mid value is greater than or equal to 0. High becomes equal to mid. Oh, wait, this is the same as before. Yeah, so it has to be 1. If mid value is greater than or equal to 1, then you keep on moving towards. So if you have a bunch of 1s, right? Mid value is greater than or equal to 1, then you want to keep on going over to the side. You make high equals, let's say you make high equals mid minus 1. So that's 3, that's correct. That's 3, that's incorrect. 4, that's correct. 1, that's incorrect. 4, that's incorrect. So you want to move, if it is greater than or equal to 1, you want to make it smaller. And then these are incorrect, but are they 1 off? Off by 1? Yeah, it's off by 1. This is correct. It's not even off by 1. This is off by 1. Okay, correct. Off by 1. So if you end up being in a spot that's negative or less, or if you end up in a spot, okay. If the low is less than high and you end up in a 1, you want to find 1 to the left of it. You want to find the earliest 1. The earliest 1 should be where I is equal to mid minus 1, so a smaller 1, smaller index. Else, if it is equal to something smaller, if it is something that is, if the mid value is smaller than 1, like its mid value might be 0, then you need to go low equals mid plus 1. Is that correct? The issue here is if it's 0, if the mid index if the mid value is 0, if you actually go to mid plus 1, then you might be at where 1 is. At that point, you might be stuck getting a 1 at the end. Because the low end, if you get stuck with a 1 at the end, then you just need to subtract 1 for the answer. Is that the way this should work? Low equals mid plus 1. Keep on going towards the left in that case. Highs equal to mid. So I think what I'm going to try here is I'm going to actually do the above average. So the mid, I'm going to do the above average. I think the above average works like, let's see, mid minus 1, this is mid. Okay, I didn't go infinite. This is 4, so it's off by 1 here, off by 1 here. This correctly gets it. Off by 1 here, off by 1 here. I think the off by 1 is where you end up in a spot where the low index value is positive or 0. So I think here, positive or negative. Negative or 0. So if the nums at low equals is less than or equal to 0, and then positive is subtracted by 1. This 3 is 2, 4, 0, 3, and then return the absolute value of the difference between count positives and count of negatives. Alright, Did I do another return earlier than that? Oh, whoops. It's the maximum of those two, not the difference. Return the max of the count positives, the count negatives. Right. Okay, so what I end up doing is the way binary search normally works in the previous case was the way binary search works in the previous case is normally if you have a range that you're binary searching through, like here, you're searching through these indices for some value, but it could be a duplicated value. So let's say you're searching for 0, it could be duplicated because you kind of want to know where the earliest 0 is, which will identify where the negatives might be, right? In that case, when you see the mid value and you see that could be a 0, you want to be going in the bottom half of the array. Now, when you go to the bottom half of the array, the low index will be the same because your low index is still low, and your high index will change because you need to reduce the high index to be something, to the farther to the left, like mid or mid minus 1. Here, if you choose to use mid or mid minus 1, I think they're kind of equivalent, but the harder to distinguish thing is when you go for the top half and let's say you're searching for 0 between two things. Your mid index is negative, so you need to go to the top half. You need to say low is equal to mid plus 1 in order to not, rather than low equals mid, because mid is already within the range. It would go infinite in that case, because mid is still the current value of low. So mid plus 1 is necessary here, and that works. That works if your average, if when you have two values that you're taking low and high of, your low is going to be on your mid value is by default low value because of the way how averages work. And so you can't go from low to mid because low to mid doesn't actually change anything. That's why you go to low to mid plus 1 when you have two values. On the flip side, if you have something where you're searching for a duplicate value and you want to go to the right side, you want to go to the highest end. Here, if you want to if you have two values and you want to have the higher average, then you do a low plus high plus 1 divided by 2. So there's two values. The mid value becomes the higher of those two values, or the higher of those two indices, and then the higher of the two values. So that when you actually, in that circumstance, when you actually say low equals mid, that's adequate because low becomes the higher of the two values, and you kind of actually don't go infinite in that case. Yeah, not really the best explanation, but it is what it is. The time complexity here should just be O of log base 2 of n or log of n. Mainly because when you do binary search, the indices that the number of times that you look at stuff is going to be halved each time, or you basically cut down your search area. Like originally your search area is all n indices. You should cut it down half each time. And if you cut down something in half and there's originally n items, then the number of times you need to cut down to 1 is like log base 2 of n. Like that's just how exponentials work. And similarly, it's another log base 2 of n to find kind of the bounds for where the negatives are and the bounds for the positives. So 2 base log 2 of n, which is still O of log n time. Base complexity is obviously just going to be 0 or constant. You're just using some variables that don't take more than a few slots of space, and you're not making any new arrays that are n size or anything.